Now, I'm not going to bother with the silly question, is this a system of nonlinear equations? Of course it is. But if you looked at that, would you recognize that that one of those equations was nonlinear? This bottom one, this is a linear equation. If you graph it, it makes a line. But does anyone know what this looks like? This is called the hyperbola. Take pre-calc. You learn all about it. They're super fun things. But what it basically means is, picture-wise, this one looks like that. And this one here is a line. Okay? And we're just going to do a really crude sketch graph. But does anyone know whether this line has a positive or negative slope? It's 50-50. If you're right, you sound smart.
Negative.
Yeah, it's got a negative slope. If you solve for y, you have to subtract the 3x over, making it negative, and then dividing by positive 2 is still negative. It's got a slope of negative 3 over 2. Okay, so it's a line that goes like this. The only other thing so we can do this sort of quasi-exact is, does it have a positive or negative y-intercept? It's going to have a negative y-intercept, so it's going to be a line like that. Meaning, I should expect how many solutions? Probably 2. Okay? But I'm not going to get them by just reading them off the graph. Deal? So how do I get them instead? I don't think elimination is going to work very well. I don't think there's any way I can add this to this and get x's to drop out or y's to drop out. Right? Or not necessarily on the bottom, but I could solve it for top or bottom. I could solve, especially here, easily x or y, right? I could just get one of them by itself by dividing off the other. So do y'all want to solve for y and plug that in, or do y'all want to solve for x? All right, we'll solve for y then. So y equals 8 divided by x. And the idea behind substitution is take whatever you got and plug that in, right? So this is 3x plus 2 times 8 over x equals negative 16. Now what? Go back to the review portion. What? Yeah, multiply the 2 out. But when I multiply the 2 times this, do I multiply top and bottom by 2? Yeah, just the top, right? So this is 3x plus 16 over x equals negative 16. Good. Now what? I see fractions. Do you? And in most cases, I don't like fractions. Do you? So what should we do if we have fractions and we don't have to have them? We should get rid of them, right? So how do I get rid of fractions? We talked about it back in section 1.6.
Multiply everything or by x, but divide it or...
Yeah, clear fractions by multiplying through by whatever you're dividing by. I'm dividing by x. So I'm going to multiply both sides by x. So on the left, when I distribute, that's 3x squared. When I multiply those kids together, yeah, it's just 16. The dividing by and the multiplying by x cancel. And this equals negative 16x. And voila, you have a quadratic equation that you need to get in standard form. And this time, I'm not sure I bother factoring. Give it 5 seconds. I don't got anything. Y'all have anything? I do think it factors, but I don't want to spend 5 minutes on something in the event that it doesn't factor, right? So if I'm not going to do factoring, what am I going to do? I say quadratic formula on this. I don't even bother with completing the square when it's not 1x squared. And I don't do, what was the other one, square root property. That's a very, very special case. So x is going to equal negative 16 plus or minus the square root of 16 squared is 256 minus 4 times 3 times 16 all divided by 2 times 3. Oh man, what's 12 times 16?
192.
192. It is 64? Yeah.
6 minus 1.
And the square root of 64 is a nice number, isn't it? And I can keep going, can't I? That is arithmetic that me and my calculator, we can handle. But there's two things we can do. We could either go ahead and split up the plus minus now, or as a fraction, there's some reducing I could do, right? All three numbers up here are divisible by 2. So if I want to make the rest of the arithmetic even easier, is I can divide everything up here by 2. So that's by notation, but there, I'm dividing everything by 2. So negative 8 plus or minus 4 over 3. And now we gotta go for it. If I'm doing the plus, negative 8 plus 4 over 3
Negative
is,
4 over 3 and negative 4.
and yeah, negative 8 minus 4 when I do the minus over 3, that's negative 12 over 3, negative 4. Okay? If you look at our picture, this was far from exact or precise. But do those look like the reasonable kinds of x values? Like this point over here, I have no trouble believing that that's at negative 4/3, right? And that negative 4 is maybe that one over there? Sure. Okay, so how do I get the y values though? Yeah, you gotta plug them in one way or another. And if I didn't let you think about it, you might go to the default linear equation because you like nice and linear stuff. But I gotta say, I think it'll be easier to solve for these y's if we plug them in for this x. Because to solve for this y, I'm just dividing that number off, right? So if x equals negative 4, then negative 4y equals 8. So there, y equals negative 2. So one point of intersection is negative 4, negative 2. And if x equals negative 4/3, then tell me, what can I do to solve for that y? How do I get rid of this negative 4/3? Don't say divide by negative 4/3. Multiply by the reciprocal, right? That's the faster, cleaner way of getting there. That way the 4's cancel, the 3's cancel, the negatives cancel, and I get y equals, let's see, 4 goes into 8 twice, so negative 6. So x equals negative 4/3, comma, y equals negative 6. Super fun, yes? Okay.